All I do is grow, grow, grow no matter what. Got growth on my mind, I could never give up. And every time I get that sinking feeling that makes me feel stuck, I just keep trying, I just keep trying, I just keep trying, I just keep trying. All right, welcome to another math lesson with Miss Jones. And today we're looking at how to subtract fractions that are greater than or equal to the number 1. Let's talk about this joke of the day. What did the penny say to another penny? What did the penny say to another penny? Or to the other penny? You're wondering? Well, let me tell you. It said, "We make perfect sense." Get it? You know, a penny is 1 cent. We make perfect sense. I thought that was really funny. All right, well, let's go ahead and dive into our math lesson. And we always like to start with a little math vocabulary. Let's just remember some things we learned in 3rd and 4th grade. That denominator of a fraction tells you, first it tells you how many equal parts are in one whole. For example, in this circle, because the denominator is thirds, we have 3 equal parts. But the denominator also tells you how large or small that number is, large or small the size of the fraction is. For example, if I split a circle into half and I divided it with 2 people, then my amount will be larger than 1/3 because each person would get more. The numerator just tells me how many equal parts I'm working with. So in this case, if it's 1/3, I'm only working with 1 of those 3 equal parts, okay? A unit fraction, we'll look at a lot of unit fractions today. It's just a fraction that has a numerator of 1, okay? It could be 1 over 1,000. It could be 1 over 4. Just tells me it's 1 piece out of however many pieces we have in the whole. An equivalent fraction, we also will make equivalent fractions today. Again, it's just a fraction that might have a different numerator, a different denominator, but it's equivalent or equal to the same amount of another fraction. So in this example in our vocabulary card here, we see that 1/2 is equivalent to 3/6 because if we divide 1 whole into 6 equal pieces, half of that would be 3 of those equal pieces. So 3/6 is exactly the same size as 1/2. Our next, and I think is our final definition for today, is a mixed number. We'll look at a lot of fractions with mixed numbers today. It really is, if we were to break it down or decompose this, it would be equivalent to 3 wholes, which each one of those whole circles has 7 small pieces. Okay, so it's equivalent to a whole number plus a fraction, okay? So we would have to add all of those pieces up to figure out what 3 wholes and 3/7 is. They are not separate, they come together. They ride together. 3 and 3/7 means that we are adding up all of those pieces or all of the value of all of these numbers to find a total amount. All right, let's take a look at our first example of the day. In this example, we're subtracting 1 1/5 minus 1/2, okay? And in order to do that successfully, we're going to need to skip count by multiples. And essentially a multiple here, like a multiple of 7s, it would be numbers, whole numbers that you could multiply and you find the product of a whole number and any other number. So like 7 times 1, 7 is a multiple of 7 times 1. 7 times 2, 14 is a multiple of 7 times 2. So essentially, we're going to use that idea to find common units. So let's go ahead and dive into our first example to make this make sense. All right, so I've been pushing myself as an educator to model the math. I've been pushing scholars to model either with a manipulative, we're going to use those in just a second, a number line, or the fractional area model. And we'll see all 3 today. Let's go. In our first example, we have 1 and 1/5. So I'm going to show you here that this represents 1 and 1/5. Now we want to subtract 1/2. Okay, so that's 1 whole piece, right? It's 1 single piece, and I'm adding on this 1/5 to represent the whole amount that we began with. Okay, it would take 5 of these to make up one whole. Now we need to subtract 1/2. We got to subtract this amount. Now it is pretty difficult to just subtract 1/2 if my whole is still in one whole piece. So the first thing I might do is rename or rename my one whole as 2/2, okay? We still know that these are, 2/2 is the same thing as one whole, so I'm not using any different size amounts. I am just renaming it so I can subtract that 1/2. So I'm going to take away 1/2 from my whole amount. Let me remove 1/2. Now that I've taken away 1/2 from my whole amount, I have my answer, but how in the world would I describe what the answer is? Would I say it's 1/2 plus 1/5? That's still not a single answer. Would I say it's 1/2 and a little less than 1? So this is why we use equivalent units, because we want to describe our answer or the solution to our problem using language that gives us an idea of the size, of our answer. So what I encourage scholars to do if they have manipulatives is try to figure out, well, what are some equivalent fractions that are shared? What's an equivalent unit shared between halves and fifths? And first of all, I would just tell them to play around with the manipulative. So the first thing I'm going to do is I have 4/4 here, which is equivalent to one whole. Okay, so I'm going to see, maybe my 2/4 is equivalent to 1/2. And it is. It's exactly the same length as 1/2. That's fantastic. So now if 1/4 is also equivalent to 1/5, I'm good to go. But what I see here is when I connect them is that 1/4 is slightly bigger than 1/5. So this is not an equivalent unit that I could use because now my yellow piece is larger than my answer. It's more. So let me now try a different unit. Let me try tenths. Let's see, if I had 1/10, is that equivalent to 1/5? No, but maybe if I added another 10th, and what I notice here is that 2/10 is equivalent or equal to exactly the same length as 1/5, so it looks like I'm in good shape. Now let me see, how many tenths would equal 1/2? Well, let me try. I am going to line up 3/10 there. That's still not enough. Let me try and add some more tenths. And I can see that 5/10 is exactly equal to 1/2. 2/10 is exactly equal to 1/5. So together, what did I have remaining? I had 1, 2, 3, 4, 5, 6, 7 tenths. So my answer would be 7/10. So that's how I would model it and play around with it to kind of figure out what's really happening. I'm changing these different size units in for units that are equivalent so that I could give you an answer that makes sense. Is I can in my mind picture that 7/10 is less than one whole and it's more than 1/2 and it's one single answer, right? So let's go ahead and model this using some math. Let's do some math. So if I'm working with mixed numbers and regular fractions, I like to write the numbers vertically because scholars are already accustomed to lining up their numbers vertically by place value. Well, fractions have a value. They are a number, okay? It's not just images we draw. They have value. And so we can relate the idea of lining up those numbers vertically like they do with any other whole number. It tends to make a lot more sense, and I tend to see scholars making less mistakes, particularly when they're subtracting fractions. Let me show you what I mean. So we're going to begin by writing one whole here and 1/5. And right underneath there, since I don't have a whole number in my second minuend, or the part that I'm subtracting, I'm just going to put 1/2 beneath. Okay, and prepare to subtract. Now, the first thing I notice, again, as I noticed when I set up the model, these denominators are different, meaning those fractions are different sizes. So if I don't have models, one method that we like to use is we do skip count by multiples of these two fractions, okay? So I'm going to skip count by halves, and I'm going to skip count by fifths. So that's 2, 4, 6, 8, 10, 5, 10. The reason I just stopped at 10 is because I've reached a multiple that they have in common. In fact, I've reached the least common multiple, meaning that I know that if I were to now change the denominators of these fractions, just like I renamed them in my example, I know that tenths would be an equivalent size that I could use and work with among both of them. So if I were to draw this, that means if I had fifths and I also divided those fifths in half, my numerator would become 2 small pieces and my denominator would become 10 small pieces. So 1 times 2 gives me 2. 5 times 2 gives me 10. So now I have 1 whole and 2 tenths, okay? Here, if I were to now represent fifths, split my halves into fifths as well, my numerator would become 5 small pieces and my denominator would also become 10 small pieces. So we would have 5 times 1 is 5, 2 times 5 is 10. Now I'm noticing if I'm subtracting the normal way I would subtract, 2 minus 5, because these are just, we can now subtract those numerators because we're looking at the same size units, okay? So if I had 2 tenths, only 2 tenths available, and I tried to subtract 5 tenths, I could not do that because I don't have enough to begin with. So I have to rename. This is the same thing we do when we're subtracting whole numbers. So let's do that. We're going to rename my 1 whole, because remember I had 1 whole and 2 tenths. I'm going to rename this, and I know that 1 whole is equivalent to 10 tenths. So I'm going to add my 10 tenths to this. So now I have 2 tenths plus 10 tenths. That gives me 12 tenths, and I'm subtracting my 5 tenths still. Okay, so all I did was rename. So now I don't have that whole anymore. I renamed it. I broke it into 10 small pieces. Okay, so now I can subtract. I have 12 tenths minus 5 tenths. 12 minus 5 gives me 7 tenths remaining. Okay, fantastic. Easy peasy, lemon squeezy. Worked out so far. So now let's relate this idea to the number line quickly. So if I'm on my number line, I'm using a number line, I would first go ahead and label an endpoint of 0, and then I had 1 whole plus 1/5. So I know that my endpoint would at least be 2 because I have 1 whole and a fractional part. I'm going to first begin by dividing my 1 whole into fifths, because I had 1 whole and 1/5 as my original unit. So that's 4 lines, equal lines, to show 5 equal parts. Do the same thing here. 1, 2, 3/5, 4/5, 5/5. Okay, so now I know that my fraction started at 1 and 1/5. So this is 1 whole plus 1/5 right here. And I'm going to take away, or I'm going to subtract on a number line. When I'm subtracting, I am jumping back the opposite direction. So I'm going to subtract 1/2. Now I already know that my whole amount, 1 and 1/5, it was already a little bit more than 1 whole. So when I subtract 1/2, it's not going to put me exactly in the middle here. It's going to put me a little bit past the middle, I think. So I'm just estimating, and I would say it's about right here. So I'm taking away my 1/2. Now I do have to estimate here because I have different fractional units, right? I have 1 whole and 1/5, and I'm taking away 1/2. But now on our second number line, let's go ahead and represent this using tenths, because we know that 10 is an equivalent unit we could work with. So I'm going to divide now this into tenths. 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths. 1 whole. 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, another whole. Okay, now that I have that, let's go ahead and subtract. So in this example, I am subtracting, I'm just trying to adjust my camera. In this example, I'm starting with 12 tenths. We realize that 1 and 1/5 is the same thing as 12 tenths. So this is 10 tenths. I know this is 10 tenths, 11 tenths, 12 tenths. So now I'm going to take away 5 tenths. So I'm going to jump back 5 times. That's 1/10, 2/10, 3/10, 4/10, 5/10. I will stop right here and I'm gonna put a dot there. And so when I want to figure out what that number is on a number line, I again start from 0. Now I'm counting forward. So 0, 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10. So we've just shown that 1 and 1/5 minus 1/2 is the same thing as 12/10. This is 12/10 minus 5/10. So that's how we would model an example like this on a number line. I do encourage scholars to use a double number line because it can help show equivalence. We can see that 1 whole is equivalent to 10/10, okay? Or 1/5 is equivalent to 1/2 here. 1/5, which is what we had, is equivalent to 1/2, and that's what we found earlier, okay? So now let's take a look and see how we can model this using the area model. Let's do another example. Okay, so in this example, let me adjust the camera here for a second so we can see everything. There we go. So let's take a look at our next example. Here we're modeling 3 1/4. And I'm subtracting 2 1/2. Oh. Again, I'm lining up my whole numbers with my whole numbers and my fractions with my fractions. And my first step is to always subtract my fractions first. When I'm writing them vertically, I subtract fractions first, and then I subtract whole numbers. The reason I'm subtracting fractions first is because I may have to regroup, okay? And so same thing when we add and subtract numbers. We start with our ones place first because we might have to regroup or unbundle from the next highest place value. All right, so let's take a look. First thing I'm going to do is I'm just going to model what I'm beginning with. So I have 3 wholes and 1/4. And to show that, I'm going to shade in 1 whole, 2 wholes, 3 wholes, and I need to represent fourths by showing how many vertical lines? 3, 1, 2, 3. And I'm going to shade in one of those to represent 1/4. Now, they want me to take away 2 1/2, and I can already see that those denominators are not the same. So if I'm thinking about, well, how do I find common units, and I don't have with me manipulatives or models, I'm going to then just go ahead and skip count. So I have halves and I have fourths. So I'm going to skip count 2, 4, 6, 4, 8. The reason I'm stopping so early is because I can already see that 4 is the multiple, the smallest, the least common multiple they have in common. And because they share 4 in common, then it tells me that I need my denominators to be in fourths, okay? That I could have an equivalent unit of fourths. So here's what I'm going to do. I already noticed that my whole, 3 wholes and 1/4, the first part of my subtraction sentence is already in fourths, but I noticed that what I'm subtracting is not. So let me go ahead and rename this into fourths. And the way I would do that is I would think to myself, well, what could I multiply by 2 to give me 4? Well, 2 times 2 gives me 4. So I'm going to multiply my denominator by 2 and my numerator by 2. Okay? And so now I'm working with 3 wholes and 1/4, and I'm subtracting 2 wholes and 2 fourths. Okay? So now that I have that, I can already see I need to now change my 1/2. This 1/2 is the same thing as 2 fourths. So let me go ahead and change one of my wholes into fourths as well. 1, 2, 3. So now I have fourths, okay? So here we go. Now I'm ready to go ahead and subtract. 1/4 minus 2/4. Well, I don't, that's just not something that I could do, right? If I have 1/4 here and I'm trying to take away 2/4, that's just not something I could do mathematically and make it make sense right now at this point in 5th grade math. So what I'm going to do is I'm going to rename one of my thirds, just like I did down here. I took one of my wholes away and I'm going to rename it as fourths. So I'm going to add, how many fourths does it take to make one whole? Well, it takes 4 fourths. So the reason I have renamed this one is because it was necessary in order for me to actually subtract these. So now I have 5 fourths minus, now I have, 2 and 5 fourths. 2 wholes and 5 fourths. And over here I have 2 wholes and 2 fourths. Now I notice my denominators are the same size. I can go ahead and subtract, okay? So let me subtract my fractions first. 5 fourths minus 2 fourths gives me 3 fourths, okay? Remember, the fourths just tell, that denominator tells me how big or small the fraction is. This is 1/4, one of these things, okay? So, and then I do 2 minus 2, that gives me 0. Well, if I have 0 as a whole number, traditionally I don't write a 0, I just leave it blank, okay? 2 minus 2 is 0, so that's nothing. So my answer is 3 fourths. Well, let's see if this works out with our model. I want to take away, I'm taking my, I had 3 and 1/4, and I'm taking away 2 and 2/4. So first I'm going to X out 2 wholes. So let me do that. 1 whole, 2 wholes, and then I need to take away 2/4. So let me take that away. I have 1, 2. Well, how many fourths am I left with? I'm left with 1/4, 2/4, 3/4. So my answer matches, my model matches my math, which is what we're always aiming to do. My answer would be 3 fourths, okay? All right, so let's look at one final example, and this time we won't use manipulatives, we'll just do the math, okay? And we'll look at one common misconception that I've seen as a result, okay? But hopefully subtracting vertically is going to be a method that scholars use, because I found it has really cut down on misconceptions. So let's take a look at another example, our final example here. Okay. All right, so we have 4, I'll go this way. Let's take a look at this one. So we have 4 1/2 minus 3 2/3. So again, we're just gonna now really quickly gonna show you the benefit again of writing those numbers vertically versus when scholars do it horizontally and the mistakes that I traditionally see. So before we do that, I do want to just draw our attention to one quick thing, the 3 steps we're using in order to subtract these fractions. Let me move myself over here. And it's just, we're going to find that least common multiple first. We're going to subtract our fractions because it's in the farthest right hand column, just like our ones place would be. Then we're going to subtract those whole numbers and we should come up with our answer. So let's go ahead and knock it out. Here we go. So first step, I'm going to find my least common multiples. That's what I'm going to do. Okay, so I can write that anywhere. I think I'm going to write it just over here. I have halves and thirds. So 2, 4, 6, and I already know that 6 is the first multiple they're going to have in common, least common one, okay? As scholars become more comfortable with this method, they're going to mentally begin to notice that, hey, I know that 1/3 is equivalent to 2 6s. You know, they'll be able to figure that out pretty quickly as they become more comfortable with the math. So just to show that equivalence, we have 1/3 and it's equivalent to how many sixes? Well, 1/3 is equivalent to 2 sixes, and we can see that, okay? But let's just go ahead and knock out this math here. All right, so now that I know that 1/3 is equivalent to 2 6, I'll leave that there. I'm going to change my denominators or my units there. So 2 times 3, what can I multiply by 2 to give me 6? It would be 3. And I'll multiply the numerator and the denominator by that same amount. What can I multiply by 3 to give me 6? 3 times 2. So this would be 6. Oops. Misconception. It would not be 6. It would be 4. Again, what I'm noticing here is I cannot take 4 6 from 3 6. That's just, I don't have enough sixes to take away, right? If I had 3 6s available, I can't just now take away 4 6s from that. So I'm going to do some unbundling here, and I'm going to rename one of my 4 1s. So instead of 4 1s, I now have 3. I'm going to rename one of those as 6 6s. So that now gives me 9 6s, okay? Or a total of 3 wholes and 9 6s. And then I have 3 wholes and 4 6s. And you can see now I'm able to subtract my numerators, okay? So I'll have 9 6s minus 4. 9 minus 4 gives me 5 6s. 3 minus 3 gives me 0. So my answer would be 5 6s. Okay? That is how I would solve that one. So let me just show you really quickly, parents, a misconception that I've seen that is quite common. Okay? And we'll use this example again. So let me rewrite this example. And instead of writing it vertically, I am going to write it horizontally, because some scholars do prefer to write it horizontally, but this is the mistake that I normally see horizontally. Okay? So I'm going to rewrite it, and we're going to look at a common mistake that is often made in 5th grade math. All right? And that common mistake is that scholars often incorrectly will subtract. Let me move myself out of the way. I'm going to move myself out of the way for a second. Sometimes scholars will incorrectly subtract a fraction that's larger. They'll try to take a larger fraction away from a smaller fraction. So this is, if they're writing it horizontally, this is what I normally see when scholars make a mistake. They will correctly identify what their least common multiple is. I'll say it's 6s, and then they might say, okay, Ms. Jones, this is the same thing as, I know I'm multiplying this by 3, this by 3. So they'll say, oh, this is, now this becomes 4 and 3 6 minus 3 and 4 6. And what I notice they will do, most scholars will do, if they're writing it vertically, they go, well, let me subtract my whole numbers first. 4 minus 3 is 1. And then they'll say 3 minus 4 is 1 6. Now we know that 3 minus 4 is not 1 6, okay? Because 3 is smaller than 6. I mean, 3 is smaller than 4, right? If I have 3 6s available, 1 2 3, I cannot say I'm going to take away 4, because I actually don't even have 4 available to subtract. But this is the most common misconception. So instead of them getting the correct answer of 5 6, they would end up with 1 6. So I do recommend that you encourage your scholars and push your scholars, if they're going to do it horizontally, to be very, very careful about making sure that if they notice this is smaller, then they need to do some renaming. They need to do some renaming. This could be 3 wholes plus 6 6 plus 3 6. Okay, that's what this would be, right? And then they would do minus 3 plus 4, 6. So then this becomes 3 plus 9 over 6 minus 3 plus 4 over 6. And now if they're subtracting horizontally, it can work out, right? 3 minus 3, if they want to subtract the wholes first, they know that's 0. 9 minus 4, that gives you 5 over 6, and they would arrive at the correct answer. So I just wanted to just kind of have that example there to show parents kind of what are some common mistakes that I see. I do want to just say, fantastic job today. Fractions is not a skill to be feared. It is a skill to be faced, you know. And I've found this school year so far in particular that scholars have been really, really successful adding and subtracting fractions, mixed numbers, because they have continued to keep trying. So remember, just because you're having trouble doesn't mean you can't try. And I promise you, you keep trying, you'll get better. You keep trying, you'll get better. And the goal is to improve. So can't wait to see you on the next math video. Thanks for taking time with me today. Be well.